Hello guys, my name is Lim Zunpi, and today I would like to present about our assignment of engineering mathematics. Before I start, I will introduce our group member, which is Tan Kiên Hao, Lim Zunpi, Lee Song, and Kashwiin, Kavundeer, and NALIRAJA. In this assignment, we will study about the uses of triple integral and simulate the integral function by using a software such as MATLAB. So before it, we have to know a triple integral is essentially a method to find the value. So any object have their own value in the three-dimension parameter dr, x, y, and z. So by integrate these three parameters, we can find the value of the object. Okay, now we look to the triple integral in a cylindrical coordinate system. So in this diagram, it shows a cylindrical object. It has a 3D parameter which stand for rho, phi, and z. So the rho is the radius of the cylindrical, like this, from origin to the outside of the circumference, and the phi is the angle of the circle, which is from 0 to 2 pi to represent a circle surface of this cylindrical object, and the z is the height of the cylindrical object. So to determine the value, we can integrate the dv of the cylindrical, which is d rho, d phi, and dz to find the value. Okay, before I stop my part, I would like to make some briefing for the MATLAB coding. So this is the coding we use. First, we have to make a declaration of the function xyz and its value. So for the triple integration part, we have to insert the range of the dx, dy, dz into the integral tree. The dx, dy, dz we also can understand as d rho, d phi, and dz. So after we run the simulation, the answer will be come out, and then by using this software, we can verify either our calculation is true or false by compare our answer with this answer. So that's all from me. I will pass to my friend and continue to proceed the following step. Thank you.
Now we will talk about the application triple integral in electromagnetic theory. As we all know, we are going to calculate the total charge of wire core of a certain radius and length, and with the value of the total charge in L, a force and the current applied into the wire, taking the following formula to calculate the power derived by wire, with the supporting of the divergence theorem in Gauss theorem, which we will known as a theorem which relate the flux of the vector field through the closed surface of the divergence of the field in the volume enclosed. So for this case, we will assume the wire came from this parameter. The 4 will be between 0 to 2 mm, the 5 will be 0 to 2 pi, the Z will be 0 to 100 mm, the force will be 1000 watt, and the current will be 2 milliampere. For the first question, which is we going to calculate the total charge, we will use the triple integer as shown as the above and the divergence theorem as shown above.
Hello, I'm Dan. Today I would like to present to you guys about total charge calculation by using the Gauss law and the divergence theorem. So first of all, we are given the condition of the electric flux density of the wire is E squared times with AP plus with 2P A phi and plus with 4Z AZ. So this AP, A phi, AZ is the cylindrical coordinate, okay, of the system. So first of all, we will have to differentiate first. Differentiate the element of the D according to each of the element. And then the formula is 1 over rho times with the differential of rho element plus 1 over rho times with the differential of the phi element plus with the differential of also Z element. So we will differentiate separately, okay. So we differentiate p square differentiate 2 row, and also we differentiate 4z separately, and we will get the answer 2 row plus 4. Alright, so the 2 rows plus 4 is the row V answer that we are going to use for the calculation of this Q, which is the total charge. So at here you can see from this illustration, this is representing the limit of the wire, which the wire has a 2mm radius, and then it has a length of 100mm, which is the Z, and also it has a circular portion is around 2 pi. So we will insert all of the limit into the triple integral formula, and first we have to know also the triple integral formula is dV, which the differential element has content splitting, which is the dV for the cylindrical coordinate is rho dp times with d phi and also dz. So just now we already got the rho v as the 2p plus 4, so we will multiply it into this dV, and then we will integrate separately. So we integrate separately, just we integrate dz, we will get z, integrate d phi, we will get pi, and then we integrate this 2 row square plus 4 row dp, we will get 2 over 3 row cube plus 2 row power of 2. Okay, so after that we will just need to insert the limit of the integration, and then each of the limit should be entered separately according to the term, and then we will multiply the answer, and in the end we will get the answer as x377 charges. Okay, so in order for us to prove the answer in the MATLAB, we will have to do these following steps. First of all, we will have to come up with the declaration of the function. And here you can see that I'm declaring the function as xyz. It's actually x is representing the row and y is representing for the phi. The reason for me to do this is because we cannot insert the specific symbol in the MATLAB, such as the phi symbol and also the row symbol. Alright, and then after I've declared, I will come up with the function of the row b, which is the 2 x squared plus 4x, is also representing the 2 phi squared plus 4 phi. Okay, after I have declared it, everything, I will have to use the integral tree formula for me to generate for the answer. So first of all, we will have to come up with the function, and then come out with the x limit, and then this will become the y limit, and the end followed by the z limit. So in the end, I will get the answer as z, which is x.377 times power of 10 power of 3, which is also the same answer just like what we calculated over here. So that's all for me. Thank you.
For the next question, we will use the power related triple integer, where the E is the electric field, F is the force that came from the voltage, J will be the conduction current, I will be the current, and A will be the cylindrical area, which is pi r square.
Hello, my name is Lee Song. I will explain the calculation of total power. This is the formula that we need to calculate the total power. We assume that the force is 1000 Newton and the current is 2 milliampere. We will get the value of electric field and current density, and we will multiply it, and we will get the value is 19. The value will as the function, and we use the triple integral method to solve it, and we will get the value is 7600 pi. This show that the calculation of total power using the triple integral method. Next, we will use the MATLAB software to simulate the result of total power calculation. In the simulation, I declare the radius as x, the angle of rotation is declared as y, the length is declared as z. This is the coding that we use to simulate the total power. The simulated result is same as compared to the calculation result. Is the calculation result 7600 times pi, you get the same value with the similar result. That's all for me. Thank you.